Hello everyone, welcome to Course Seeded. So today we'll be studying about graphs and trees. So basically it will be just the info of graphs and trees. There will be no code for today, or we'll have some code. So a graph is basically a 2D matrix or 2D vector or array, whatever you want to call it. So it's basically a 2D matrix which consists of vertices, which are basically called nodes in graphs, and it contains edges. They can be either weighted or unweighted. Weighted slash unweighted. So by this what I mean is, suppose you have a graph of size 5. So basically it will look something like this. This is the most basic graph you can make. So basically this is the graph of 5. Or you can make a single layered graph. Not single layered, but like you can say a single line graph. So basically this is the most basic way to represent a graph. So, or you can represent the graph like this, or even you can do it like something like this. So basically this is of n equals to 5. So there are multiple ways to represent a graph. In the question you will be asked accordingly with which node what is connected. So basically you don't have to worry much about that. So for now what you have is basically there are two types of graphs, directed and undirected. So suppose if I say there is an undirected graph. So in directed graph, you point towards the node, whether this is pointed towards this or this. So suppose if this node is 1 and this is the second node, then 1 is pointing towards 2. So 1 points towards node 2. And suppose if you have like this and this. So this is basically called a cyclic graph in which you form a cycle. So the cycle should be complete and you should be able to reach 1 from going from here to here. So basically this is known as cyclic graph and it should be of more than size 2. So let's continue with what I was saying. So basically there are different types of graphs and everything. So one by one we will be discovering everything. So for now let's just check what basic thing we can do with the graph, or what is the basic code for graph. So you just have an adjacency list, or you can say adjacency vector, in which you store the graph's edge and node. So basically which node is connected to what node, you'll be storing that in this adjacency list. So suppose this is over here, and then you just have to push. PV means pushback. So you'll be pushing, suppose there are two nodes. So basically you'll be pushing U over here and V over here. But in case of directed graph, you won't be doing both of them. So first we'll be learning about undirected graphs. So we'll keep undirected graph as our reference for now. And next we'll be moving to directed graph later on. So first we remember that we are doing undirected graph first. So over here you can go to vector, and then again vector int, and then you can have adjacency and size, and then you can just have like adjacency u dot pushback v. So if I want a graph like this, 1, this is 2, this is 3, this is 4, this is 5, over here we have 6, and then we have 7. Suppose we have 8 over here, 9, 10, and then these two are connected by themselves. So what we will be doing is, we will first count the number of edges. So this is the first edge, second edge, third edge. So basically there are total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 edges. So number of edges equals 10. Yeah, so basically we have number of edges as 10, and we have nodes from 1 to 10. And basically you can't skip a node in between, otherwise it will be a problem in graph. So 10 nodes and 10 edges. So for this, what you can do is you have to write a code in which you'll have 2D matrix or 2D vector in which you have to store, or vector of vector you can say. You'll have vector of vector in which you have to store for first index. You have to like add all the stuff which is being connected with 1 in the graph. So for 1 we'll have, well, basically adjacency 1. You should have 2, 3, 4, and 8. 2, 3, 4, and 8. And then for adjacency 2 you should have 1 and 7. You should have 1 and 7. And for adjacency 3, you should have 6 and 1. And for adjacency, and so on. Basically for all of that you'll have just write the code. So basically let's take a shorter example or smaller example for this. So basically when you have 1, 2, 3, and 4, you just have to like uh, make a graph in which you can just store all of them. 1, 2, 3, and then 4. Also over here, just tell me what adjacency of 1 should be, what adjacency of 2 should be, and adjacency of 3. Basically what is adjacent to 1, what is adjacent to 2, what is adjacent to 3, and what is adjacent to 4. You just have to tell me all that. So adjacency of 3 and adjacency of 4. Well, basically adjacency of 4 is a vector in itself, so it will have some values. So adjacency of 1 has 4, 3, and 2 as the adjacent, like as the adjacent stuff. Well, this is not necessary that it will be in the same order. It can be 4, 3, 2 or 3 to 4 also. 3 to 4. So order doesn't matter over here. So I'm writing this not in the order. So next we have for 2. For 2 we have 1 and 3. 1, 3. For 3 we have 1, 2, and 4. And for 4 we have 1 and 3. So basically this is what we have. So next we have like adjacency we have done. So now try to implement the code by yourself for this graph. You'll have the input as input n equals, basically you'll have to take n as the input, which is 4 over here, and then you'll have 1, 2, 3, 4, 5, and then you'll have m, which is the number of edges, which you'll have 5 as the, we're gonna write this edges, and then nodes equal 4, edges equal 5. And then you'll have a graph vector, a 2D array, or you can say whatever you want. So a 2D graph, a 2D vector in which you will be storing the graph. So basically graph will just tell you at what uh, node what all are connected. So for each node you'll have the like the data for each node, what all it is connected to. So next you have to take the input. So basically you'll have to go in the loop I equals 0, I less than m, I plus plus. And then what you can do is you can just take each input like this. You'll have like integer u comma v. Basically most of the time we take u and v as the input, and then we'll have u and then v, and next we can have like push it inside the graph. So at uth index you push v, and at vth index, so what this code is doing is basically, so this means push v at index u, push u at index v. So these two are the things that we have to do. So next we have like this we have done. So next we can just output the graph, and after we output this, we are done for today. So basically we can just use the auto keyword, so it'll be easier for us. For G is to graph, and then in that we can do like for auto node S to G, we can like just see out, and basically what you'll have to see out, then I plus plus. Yeah, so let's continue. So basically I forgot to give the input over here, so let's check what input we can give. So basically we have one with 4 and one with 2, one with 3. So we'll have 1 2 1 3 1 4, and then we have 2 3 and 3 4, 2 3 and 3 4. Rest it should cover by itself, so we should have this as the input. Rest you just, this was to be written cout node and this, and cout handle. So basically this is it. So next we have this over here. So we have written everything. Next we just have to write this, and the output should look something like this. Like for 1 we will have 3 to 4, for 2 we will have 1 3 3 1 to 4 4 3 1, or 1 3, in whichever order we'll write this. It will just give us the output or input. So basically it will include these three. The order doesn't matter, as I've already told you. In graph, order doesn't matter for now. So we have 1 2 and then 1 3. Next we have 1 and 4. Next 2 3 and 3 4. Let's see if we get the right answer. So let me first cross check. 1 2 1 3 3 1 4 2 3 3 4. So this is correct. Okay, so for 0, oh yeah, for 0th index we don't have anything, so we are getting 0 as the output. So this is correct. But if you don't want anything over here, then you can just like, okay, so basically I have to do this. Yeah, so now it will be correct. So for 0th index we don't have anything. For first index we have 2 3 4 1 3, and then 1 2 4 and then 1 3. For 2 and 4 we have 1 and 3 as the nodes which are connected to them. So basically this was there, and for this we had 1 to 4, and then for this we had 2 3 4. So we are getting all the answers correct. So that's it for the graphs and the connected nodes. Well, tomorrow we'll be talking about DFS, BFS, and other stuff. So for now, let's stop it over here. So thank you, everyone. Thank you for joining. Let's see you tomorrow. Thank you.